Hello friends, today in this lecture we are going to discuss about abnormal combustion in SI engines. Initially we will be briefly discussing about normal combustion in SI engines followed by abnormal combustion. We will also discuss about the effects of abnormal combustion, factors required to control the abnormal combustion in SI engines. So let us start. So basically we should know how the combustion process in SI engine happens. So basically, any combustion, we can say it as a hydrocarbon fuel is burned in air to form carbon dioxide and water, and it is liberating here heat. So this is your hydrocarbon. This is oxygen taken from the air, and it forms carbon dioxide and water along with heat. So and the required things in order to this particular combustion to happen is first the presence of combustible mixture. So we have to ensure that the mixture available is within the inflammability limit in order to ensure the combustion. There should be some method to ignite this particular mixture. So preferably we know that we are using a spark plug for igniting the mixture. And after ignition, when the flame is going to be generated, we need to ensure that the flame is going to propagate inside the combustion chamber. And here we need to take care that a proper selection of the type of combustion chamber is going to be there, so that the flame is going to be uniformly distributed without unevenness in the combustion process, so that we can say a smooth combustion is happening inside the combustion chamber. And we also need to ensure that all the fuel and all the air inside the combustion chamber is going to be utilized. And for this to happen, we have to ensure that the shape of the combustion chamber is proper, the spark plug location inside the combustion chamber is proper, and the flame velocity is also flame velocity along with the size of the combustion chamber is also going to matter. So when all these things are proper, we can ensure that air and fuel is going to be properly burned inside the combustion chamber without any abnormality. Now let us discuss how the normal combustion happens. So we know that a homogeneous mixture is supplied in a controlled manner into the combustion chamber, and this is burned in a controlled manner. And here you can see the different stages of combustion in a SI engine. So we have generally three stages. First stage is called as a ignition lag, second stage is called as a flame propagation stage, and third stage is called as afterburning. Now the first stage, what happens in a first stage, from here you can see A to B. In this particular first stage, ignition lag, a nucleus of the flame is being generated inside the combustion chamber with the help of a spark plug. So a spark is given at A and a nucleus is being generated, and this is converted into a full-fledged flame in the ignition lag period. Now second stage is your flame propagation stage. In this particular stage, which starts from B, flame starts, which is a fully fledged flame, is going to travel across the combustion chamber, starting from the spark plug location to all the other corners of the combustion chamber. And finally, we reach the point C, which is the point corresponding to the maximum pressure inside the combustion chamber. And in the third stage, we have, which we call as afterburning, you have what we call as unburned mixture remaining here and there, that is inside the dead pockets are going to burn. And as the piston has started moving downwards, this particular burning is not going to contribute in the work development process of the engine. So this is what we call as a normal. So here we have a very controlled burning as per plan. So A to B something happens, B to C something happens, and then C to D something happens. So we have here A to B, flame is being developed, then B to C, a flame travels across the combustion chamber, and C to D, wherever something here and there remaining is going to burn. And this happens very smoothly, and when this happens very smoothly, we call it as a normal combustion. But we do have some abnormal combustion taking place in the combustion chamber of SI engine. So here you can see this particular PTT diagram shows normal combustion curve, and here it shows the abnormal combustion curve. And so let us discuss what this difference is. So basically we know that spark is given when piston almost reaches the combustion chamber, that is at point A, whatever we have discussed earlier, and the nucleus is being generated over here. So the nucleus of flame is being generated, and that particular nucleus of flame is going to be going to travel across the combustion chamber. So here what is shown is it is traveling in this region. So flame is being developed over here, and it is going to travel in this direction. So spark plug is located over here, and it is going to travel in this direction now. So the flame is going to travel across now, and as it travels throughout the mixture, what is happening is this is your flame front, and as the flame front goes on moving from this location towards the other end, the here you have the unburned mixture, and on this side you have the burned mixture, that is products of combustion. So obviously the whatever the liquid fuel was there, it is being converted into gases, and therefore the mixture here it is in the gaseous form. So this particular the volume of this particular mixture is higher, due to which the pressure on this particular region is going to increase, and due to this higher pressure on the back side of your flame front, so this is your flame front, so on the back side of your flame front the pressure is higher, and due to that the unburned mixture is getting compressed. So as the flame moves towards the end, the mixture at the end mixture, that is the mixture in this particular region, is getting more and more compressed. Now when this is mixture is getting compressed over here, due to the higher compression happening due to the pressure applied by the flame front, the end mixture is reaching self-ignition temperature, and if this particular the end mixture is allowed to remain at a self-ignition temperature for some amount of time corresponding to the delay period of the that is the first stage of combustion, the end mixture is going to burn. So what happens, this end mixture burns, and a new flame is generated, and it starts traveling in the opposite direction. So a new flame is going to be developed over here, and this particular new flame starts traveling, while our earlier flame which was main flame which was produced by the spark plug is traveling in this direction, and a new flame started in this direction, and this particular two flames collide over here, producing a huge noise, and this is what we call as knocking or abnormal combustion in case of SI engine. And this is what is shown, that is almost at the end of the combustion process, burning process. Here you can see over here the flame reaching at the almost at the end of the combustion chamber. What is happening? A new flame is started generating, and both the flames collide over here, resulting in a huge noise and vibrations. So this is what generally happens in a abnormal combustion. So this is what we call as knocking in SI engines. Now let us discuss what are the effects of abnormal combustion. So this is the normal combustion, and this is your abnormal combustion, and what are the effects? So obviously the two here we said a flame is traveling in a normal without any abnormalities, uniform manner, consuming all the mixture. But when we say abnormal combustion, what is happening? The flame is traveling, but another flame is going to start from the other side, other end of the other corner of the combustion chamber, and these two flames are going to collide, and a huge noise is being produced. So noise and vibration is going to be the first. That is your generally the firing, the smooth firing, generally what we experience in a petrol engine, now it starts giving noise. So noise is there, and it is accompanied by vibrations, because the two flames collide and they produce huge vibrations. So mechanical damage. So due to this particular higher mechanical stresses produced, there is going to be mechanical damage in the different parts related to combustion chamber. Then when this knocking combustion is happening, when the two flames are being collided, whatever the vapor molecules are there, they are going to combine together, and they are unable to burn in the available time, and they are forming carbon and getting deposited somewhere in the combustion chamber. So the carbon deposit is going to be the higher. Then due to this particular collision of these two flames, there is high turbulence created inside the pressure combustion chamber, and due to this particular high turbulence, heat transfer to the combustion chamber walls is going to be higher, and due to the higher heat transfer, the heat losses are going to be more, and when the heat loss is more, the net output produced is going to decrease, and when the net output is going to decrease, the thermal efficiency of the engine is going to decrease. And one more effect is there, very important effect, that is when a huge collision is there over here, that is resulting in a turbulence, and a lot of heat is being transmitted to the all the parts of the different parts inside the combustion chamber, and they get heated up. And when they get heated up, the probability is that in the next cycle, this particular heated parts, for example the spark plug or any other corner, is going to be heated up, and that is going to remain hot enough to burn the mixture in the next cycle. So what happens in the next cycle, before the spark is being generated, this particular hot part is going to start a flame, and this is what we call as a pre-ignition. So a new flame is being started due to this particular hot part, and a flame is being generated due to spark plug. They collide, and this results in abnormal combustion. So what happens, due to the abnormal combustion, pre-ignition happens, and due to pre-ignition again knocking happens. So knocking results in pre-ignition, and pre-ignition results in knocking. So that will be forming a chain, and the firing becomes very rough in this particular condition of operation. And how to control this particular knocking combustion in SI engine? So this is what we have, a knocking combustion, that is the two flames are being collided, and the first is self-ignition temperature of the fuel factor. So if the self-ignition temperature of the fuel is higher, then what happens is the main flame is traveling over here, but this mixture is unable to reach the self-ignition temperature, because the self-ignition temperature of the fuel is higher. And since this end mixture is unable to reach the self-ignition temperature, the new flame will not travel back, a new flame will not be generated, and it will not be traveling back. Therefore, you can control the knock by ensuring that the self-ignition temperature of the fuel is higher. Second parameter is compression ratio. So by increasing the compression ratio, what happens when we increase the decrease the compression ratio? So when we decrease the compression ratio, the temperature inside will be lesser, and when lesser temperature is there, the end mixture will be requiring more amount of time to reach the self-ignition temperature, and therefore the probability of the knocking will be lesser. Then inlet air temperature, if it is lesser, what happens? The probability of end mixture reaching the self-ignition temperature is going to be lesser, and therefore that will result in lesser knocking. When the cylinder wall temperature is lesser, obviously the probability that end mixture will form a flame is going to be lesser, and therefore the knocking tendency will be lesser. And then we have the next parameter to be engine speed. So if the engine speed is high, we know that we have less time for the combustion process to happen. That means we are not giving enough time for all these things, starting a new flame and coming back and all these things to happen, and therefore we have the probability of the knocking to be lesser. Cylinder size, if it is smaller, so when the cylinder size is smaller, the flame is not going to travel a longer distance, and if because if we are allowing it to travel a longer distance, then it goes on compressing the end mixture, and more it compresses, more will be the heat in the end mixture, and that the probability of reaching its self-ignition temperature will be higher, and therefore if the size is smaller, we have a less probability of knocking in case of SI engines. And if the ignition lag is longer, that is, if the end mixture to reach the ignition, it has to reach the self-ignition temperature and remain there during the period of ignition lag, then it can start a flame. So if the ignition lag itself is longer, before the ignition lag period is over, the main flame will burn all the mixture, and there will be no probability of the second flame will be lesser. So like this we can control the knocking. Thank you.